Slay the Spire source code's out and half of game dev is reading it to learn how to make a card game. I haven't read it, but I've been building my own card game for the last 3 years and I had to solve the same problems they did. How do you make card effects that do not turn into a pile of if-then-else statements? I will show you the pattern that I ended up with. Every card game above a certain level of complexity just converges on some version of this. I will show you my code, not their code. When you start building a card game, your first instinct is to write a big switch statement. If card names equal to credit faucet, increment the player's credits by 3, or hey, if the card name is draw 2, take 2 cards from the deck and add to the player's hand. So this works for about 10 cards, and the 11th card, then the switch statement starts getting kind of long. It's starting to ask questions that it can't answer on its own. For example, was this the only card that you played this turn? Readability gets hard because there isn't a clean place where the card logic lives. It's all jammed up into this big bag of if-then-else. At this point, that's when you stop writing switch statements and start writing an effect system. Every card in my game does one of two things. It either fires immediately when it's played, for example, gain 3 credits right now, or it creates something that sits there and waits a moment later. For example, during this engage phase, add a d4 to your dice pool. These are two completely different life cycles and they need two completely different types of handlers. In my game, I call one ActionHandler and the other one EffectHandler. Whatever the names, the split is similar or the same in every digital card game I've seen. An immediate on-play effect versus a persistent thing that waits for its moment. For those of you familiar with Golang, this is the function signature of the action handler. That's it. One function type, takes a context, returns nothing, runs when the card is revealed, then it's done. So I have an example of the simplest possible handler. This is the handler for credit faucet. That's the whole implementation there. Here's a slightly more interesting example. Huddle. If this is the only card you play this turn, gain 5 credits. The logic lives in the if statement. The context exposes cards played this turn as a primitive, so the handler doesn't have to reach too deep into the game logic, game state itself. That way, if I change the way that credit gaining works, then I have one place to change, not 40-something handlers to change. When a card is played, the engine looks up its content ID in this map and calls a function. That's the whole router. It's a map from strings to function pointers. The compiler catches typos, and adding a card is one line here in the registry and the actual function handler. I'm not using reflection tricks or even class inheritance. Golang discourages construct that the language considers magical. So the map isn't a clever choice, it's just a natural way to wire this up, which is fine. The map is the registry. A reasonable question here is, why is this in code at all? Why not express every card effect as configurable data, like a row in a spreadsheet or completely in a JSON object, something a non-programmer could author? My version splits the difference. Every card in this game has a JSON file. It has name, costs, flavor text, rules, etc. That's pure data. But the thing, the effect that the card does when it's played is a Go handler in code, 2 artifacts per card. The data side gets version controlled as part of card authoring. The code side gets the full language support when it needs to do something complicated, loops, conditionals, arbitrary composition. You use each for what it's good for. Half the cards in my game don't resolve immediately. Consider podcast interview. The rules text is, gain 1d4 for this engage phase. When you play this card during the main phase, the engage phase doesn't start until later. So the card doesn't do anything yet. It has to leave behind something, a little piece of state that wakes up when the right moment arrives. One line. It registers the effect named podcast interview d4 and walks away. The actual work is happening somewhere else at a different time. The effect handler has a different signature. This one gets called every time any event happens. It returns a boolean, and when it returns true, that means, hey, I'm done, remove me from the effects list. False means not yet, keep waiting. The handler in full looks something like this. First 3 lines is, hey, is it my moment to act? No, then keep waiting. When the engage phase actually starts, the engine fires an event called event engage dice setup event. Now, when it happens, the check passes, the handler adds a D4 to the player's dice pool, records a modification, and then the UI can animate it later. Then it returns true to delete itself. That's the pattern. So the event bus is a queue, push events in, and when it's time to work on events handling, we take one from the queue and present it to every single effect handler that's currently registered. Like, here you go, this is the thing that happened. And for each event handler will do whatever it needs to do, and it's entirely possible that new events enter the queue as a side effect of running. So this is kind of like the implementation of combos that trading card games are famous for, where one effect causes another effect to happen. In my game, the combos that happen the most are, hey, effects that cause dice rerolls, and the reroll trigger yet another effect. The bus doesn't need to know anything about the cards, it doesn't need to know about dice, it's just a pipe. The effects are what gives it meaning. Drop in a new effect handler, and events are disconnected from the handlers. Nothing new to hook up. The engine of this machine doesn't need to change. Somewhere along the way, I went back and flipped through a book called Design Patterns, Elements of Reusable Object-Oriented Software, more colloquially known as the Gang of Four book, just to see if there were some design patterns that are actually named. Looking at it, looks like we got action handlers in my game are a lot like the command pattern. The effects waiting for the event bus is kind of like the observer pattern. The registry is roughly strategy. I didn't literally open the book, but these patterns are 40 years old for a reason. Also, if you've been trying to implement your own card game in Godot, you surely would have come across the well-written article by Casey Yano called On Evaluating Godot. This came out at the time when Megacrit was evaluating their move from Unity to Godot. This article is a treasure trove of all learnings for all Spire game devs, including how they write code to manage all their card effects. The pattern isn't novel. Every card game above a certain level of complexity ends up with something near this shape. A handler registry, context as API, defer effects, event bus, different names, different languages, same bones. We're ending on a cliffhanger today. Why am I spending this whole video talking about Golang and not Godot? Find out in the next video. I'm a solo developer working on a 3-player mobile card game. If you're working on your own TCG and solve this differently, I want to see it. Drop your approach in the comments. See you in the next one.